All right, guys, here we go with 5-3. We're moving forward into some more of our identities. If you take a look at your identity sheet that I hope that you have printed and in front of you while you're going through all of your homework, you will find that we have two sections here for 5-3. Now, cofunction identities, you guys already know. We have already dealt with cofunction identities. We know that the sine of an angle is equal to the cosine of its cofunction. The cosine of an angle is equal to the sine value of its complementary angle. I said that wrong. I've been making videos for 3 hours now, and my voice is getting tired. Anyway, cofunction identities depend on the complement. Cofunctions have the same value as the complement of the angle. Those are not new. What is going to be new are these sum and difference identities. We're going to tackle the cosine sum and difference identities in 5-3, and then we'll come back and we will hit the rest of those sum and difference identities, I believe, in 5-4. There's a ton of identities on this page. You do not have to memorize them all. You will be allowed to use this on your exam. You do have to be familiar enough with them to know what you're looking for. It is not going to help you to have this page if you don't make the mental connection. Oh my goodness, tangent square and secant square tie together in this Pythagorean identity. Or, oh my goodness, look, that looks like one of my sum or difference identities. And then you can go look to see which one it is. If you don't know where to look, having the sheet isn't going to be as helpful as you think. So make sure that you're doing the practice. Okay, difference and sum identities for cosine. First, we're going to prove to you that cosine of A minus B is not the same thing as cosine A minus cosine B. If that were true, if these two things were equal, then I could say that the cosine of pi half minus 0 would be equal to the cosine of pi half minus the cosine of 0. Now, pi half and 0, these are radian values. Look at your unit circle. If you don't know these by heart already, look at your unit circle. Well, let's look at the left side. Pi half minus 0 is just pi half, right? So that would be cosine pi half. What is the cosine of pi half? Well, pi half is my 90-degree angle. Up here, cosine is 0. So the left side of that equation is equal to 0. On the right side, we just said cosine of pi half is 0. What is cosine at 0? Well, the cosine at 0 is 1. So the right side of my equation, 0 minus 1 is negative 1, and 0 is not equal to negative 1. Remember that if I can find just one counterexample, it's not an identity. So cosine of A minus B, where A and B are two different angles, is not the same thing as cosine of A minus cosine of B. Instead, I have an identity for that. Cosine of A minus B is the same thing as cosine of the first angle times cosine of the second plus sine of the first, sine of the second. Notice that the algebraic signs are not the same here. If I'm finding cosine difference, I add. And if I'm finding cosine sum, I'm going to subtract. So there's my other identity. We're going to write them down so that you have it in your head. We remember things better when we write them. A and B are just first angle, second angle. But notice again, if I'm doing cosine sum, I'm subtracting the two products. If I'm doing cosine difference, I'm adding the two products. Okay, how do we use that? Well, we use those identities with our special angles on our unit circle to find values for other angles. Ready? Here we go. I need to figure out the exact value. That means I'm not using my calculator. I have to do it using identities. If I just needed an approximate value, I could just use my calculator, but that's not going to help me find an exact value. So I need to come up with two angles on my unit circle who either add or subtract to give me negative 75 degrees. So let's look at our unit circle. I've done this already, so I can tell you that 45 minus 120 is negative 75. So here we go. that's going to be the same thing as cosine of 45 degrees minus 120 degrees, because 45 minus 120 is negative 75. Now we just said that I can't just go find those two cosine function values and subtract them. I have to use the identity. This is cosine difference because I'm subtracting. Cosine difference, this is the identity I use. Angle A is 45 degrees, angle B is 120 degrees. Cosine difference. Cosine A, cosine B. So that's cosine 45 degrees, cosine 120 degrees. Plus, because cosine difference, I find the sum of the products, sine of 45 degrees, sine of 120 degrees. Don't forget your degree symbols, otherwise you've got radians, and that is not the same thing, guys. Make sure you use your degree symbols. Now I'm going to use my unit circle to find these values, unless you know them by heart, which would be lovely. Cosine of 45 degrees is square root 2 over 2. I see that on my unit circle. Cosine of 120 is a negative 1/2. Sine of 45 degrees is also square root 2 over 2, and sine of 120 is a positive square root 3 over 2. When I multiply these together, I end up with negative square root 2 plus square root 6 over 4, or I can write it as square root 6 minus square root 2 over 4. Those are equivalent values, whether it bothers you to have that negative hanging out in front or not. All of these, just a hint, all of these are going to look like that because the only values on my unit circle for these special angles, square root 3 over 2, 1/2, square root 2 over 2, all the way around, positive or negative. Let's do the ones with degrees first. So let's do C next. And then we'll move over and do B and D where we're working with radians. Cosine 15 degrees. To get to 15 degrees, I'm going to say, you know what, the easiest way for me to get to 15 is to do 45 minus 30. So I'm doing cosine difference again. Once I've written out what the identity tells me to find cosine difference of A and B, then I plug in the values that I know they represent. And again, all of these are going to look very similar with those square root 6, square root 2, and a denominator of 4. Okay, before we move on to D and E, we're going to move across the page and do B and oh, I've got 2 D's. I need to fix that at some point. Anyway, we're going to move over here. A, B, C, D. This should be E and F. That matters nothing right now, but there you go. Okay, let's do B. Now, common denominators, because I do not have any 12ths. I do not have any 12ths on my unit circle. So I need to think about things that have common denominators that are 12. My denominators on my unit circle are going to be for radian angle values. I've got 6, I've got pi 6, I've got pi 4ths, I've got pi 3rds, I've got pi halves. So I'm looking for things that have that common factor of 12 and things that add to 17. I need to find values that are going to add to 17 and be able to reduce to special angles on my unit circle. I was going to write this on the board, but I think I'm just going to pull a blank sheet of paper out and we're going to do it on that. So let's reason through this a bit. I already have one, so I'm just going to throw it out there for you. I can get to 17 a bunch of ways. Now, addition is sometimes easier. We're just going to do addition for this. We did cosine difference over here. We're going to do cosine sum. 17 would be 10 plus 7. It could be 5 plus 12. It could be 2 plus 15. It could be a lot of different things. The one I'm going to pick is 9 plus 8. 9 plus 8 is 17. Now the reason I'm going to pick 9 plus 8 is because these are both going to be reducible if I put them over 12. And hopefully they're going to reduce to special angles on my unit circle. Now, here's how I'm thinking through this. I need to end up with 17 pi over 12. So 10 plus 7 is 17. That means I would have to start with 10 pi 12ths plus 7 pi 12ths. Well, 10 pi 12 reduces to 5 pi 6, and that's a special angle in my unit circle. This one does not reduce, so that doesn't help me. That one's not going to work. If I do 5 pi 12ths plus 12 pi 12ths, that's just pi. That's a special angle on my unit circle. But that one doesn't reduce to a special angle on my unit circle, so that doesn't help me. Again, 15, oh, you know what? That one might work. Let's do that. 2 pi 12 plus 15 pi 12. That reduces to pi 6. This one reduces to 5 pi 4ths. That one works. Those are both special angles on my unit circle. I could use those. The one that I worked it out with already, so we're going to use it, is 9 and 8, because 9 plus 8 is 17. So 9 pi 12ths plus 8 pi 12ths gives me 17 pi 12ths. 9 pi 12ths reduces to 3 pi 4ths, and 8 pi 12 reduces to 2 pi 3rds. Again, both special angles on my unit circle. So either one of these will work to use my cosine sum identity with. We're going to pick this one because I've already worked it that way, and I can make sure that while I'm talking to you, I don't make any more mistakes than I have to. Okay, so cosine 17 pi 12ths is the same thing as cosine of 9 pi 12ths plus 8 pi 12ths, and we just said that 9 pi 12ths and 8 pi 12ths reduce to special angles 3 pi 4ths and 2 pi 3rds. Now I'm going to use my cosine sum identity. Cosine sum identity is cosine of the first angle, 3 pi 4ths, times cosine of the second angle, 2 pi 3rds, minus sine of the first, sine of the second. That's my cosine sum identity. I subtract those products. Now I'm going to pull out my unit circle, and I'm going to find 3 pi 4ths. 3 pi 4ths, there's cosine and sine function values. And I'm going to find 2 pi 3rds right there, cosine and sine function values. And I'm going to plug in what I know. Cosine of 3 pi 4ths is a negative square root 2 over 2. Cosine of 2 pi 3rds is a negative 1/2, minus sine of 3 pi 4ths is square root 2 over 2, and sine of 2 pi 3rds is square root 3 over 2. When I put all that together, a negative times a negative is a positive, so I've got square root 2 minus square root 6 all over 4. Again, looks very, very similar to what we had previously. Okay, let's do the next one. Cosine of 5 pi 12ths. Play with some angles that will be reducible to special angles on your unit circle whose sum add to 5. Well, 5 is 1 plus 4. 1 pi 12 doesn't reduce, or 2 plus 3, and that's going to work. So I've got cosine of 2 pi 12 plus 3 pi 12. So I can write 5 pi 12 as that sum. And those angles reduce to special angles on my unit circle, pi 6 and pi 4, both angles in quadrant 1. I plug in the values that I know, and I'm going to just cut to the chase, let you guys do that step without me showing you, and this is what you should get. Okay, these final two problems, E and F, if you fixed my lettering, show the other side of my cosine sum and difference identities. We have been starting with the left and going to the right to use it. Now we're going to start with the right and go to the left to use it. We've got cosine 173 times cosine of 83 degrees plus sine of 173, sine of 83 degrees. That's cosine A, cosine B, sine A, sine B. I'm adding in the middle, so that is cosine difference. Cosine of angle A is 173 degrees, angle B is 83 degrees, and 173 minus 83 is 90. What's cosine at 90 degrees? 0. You guys do the same. We're doing cosine sum this time. And we get 1. Okay. That's how we use our cosine sum and difference identity before we get to thinking about verifying identities. Cofunction identities. Again, this is all review. We did this. The trig function of an angle is the same as the cofunction of its complement. Now, the new thing here is that before we always worked with acute angles. Now we're going to work with any angle. So what this says, for example, is that the cosine of 30-degree angle is going to be equal to the sine function value of a 60-degree angle, because cosine and sine are cofunctions, and 30 and 60 degrees are complementary angles. Cofunctions, cosine and sine and cosine, tangent and cotangent, secant and cosecant. Those are my cofunctions. So cosine of 90 minus theta is equal to sine of theta. Sine of 90 minus theta is equal to cosine theta. Tangent of 90 minus theta is equal to cotangent theta. And then fill in the rest. So you have to do two things. You have to identify the cofunction. You have to identify the complement. All right. Notice that I did it in degrees. I could have just as easily replaced 90 degrees with pi half to use radians. All right, for A, secant and cosecant are cofunctions. That means theta is the complement of 62 degrees. 90 minus 62 is 28 degrees. That's the value of theta. Tangent and cotangent are cofunctions. That means theta is 90 minus a negative 54. So theta in this case is 144 degrees. Again, we're not staying with just acute angles. Go ahead and practice with D and E, and then we'll come back into our two radian values. All right, when I'm dealing with radian angles, instead of starting with 90 minus, I'm starting with pi half minus. Cosine and sine are cofunctions. So x is going to be pi half minus 7 pi 6. Have to find a common denominator to add or subtract fractions. So that would be 3 pi 6 minus 7 pi 6, which gives me 4 pi 6, negative 4 pi 6, excuse me, which is a negative 2 pi thirds. Cosecant and secant are cofunctions. So x is going to be pi half minus 3 pi fourths. Need a common denominator. X is a negative pi fourths. Okay, let's apply our identities that we've been working with. Reducing cosine difference to a function of a single variable. Start with what you're given. Make sure that you have your goal clearly in mind. We are going to rewrite cosine sum, cosine of 90 degrees plus theta, as a trig function in terms of theta alone. You're going to use your identity and you're going to fill in what you know. Cosine 90 degrees plus theta, cosine sum identity, cosine of the first angle times cosine of the second minus sine of the first angle, sine of the second. I don't know anything about theta because theta could be anything, but I do know cosine and sine of 90 degrees. Cosine of 90 degrees is 0, and anything times 0 is 0. Sine of 90 degrees is 1. So I'm left with a negative, and I don't have to have that 1 there, negative sine theta. I started with what I was given, and I wrote it in terms of theta alone. All right, let's do the next one. You guys work it out, and then check to make sure you knew what you were doing. Cosine difference I find the sum of the products. I use my identity, I fill in what I know, and I simplify. Awesome. Okay. Now, example 4 is not hard. There's actually nothing new here for you. It's just kind of a lot of work. It's a little bit time consuming because we are dealing with information about 2 angles. That means I need to sketch 2 angles and I need to find the missing values for each of those angles. I have information about angle S and I have information about angle T, and they are both in quadrant 4. Quadrant 4 means that cosine is going to be positive, but sine is going to be negative in quadrant 4. So let's fill out what we know about angle S, and then we're going to do what we know and what we need to know about angle T. Angle S, I'm going to sketch angle S into quadrant 4. I know that cosine is 15/17. So cosine, my x coordinate is 15, my r is 17, and I need y. Y is going to be negative because I'm in quadrant 4. So x squared plus y squared equals r squared. R is going to be the negative square root because I'm in quadrant, no, r, we know, r is 17 squared. Let's go again. Y is going to be the negative square root of 17 squared minus 15 squared. That's how I find y. We know it's negative because we know we're in quadrant 4. Y, when I do that math, comes out to be negative 8. So for S, x is 15, y is negative 8, and r is 17. Now I'm going to come over here and I'm going to find out my missing value for t. T is also in quadrant 4. I'm given sine of t. Sine is negative 24, r is 25, and I need x. So x squared plus negative 24 squared equals r squared. X is going to be positive because I'm in quadrant 4. 25 squared minus 24 squared, x comes out to be 7. So x is 7, y is negative 24, and r is 25 for angle T. Now that I have that information, I'm going to use it to solve what I was looking for. I was told to find cosine difference of s minus t. Cosine of s minus t. My identity says that is cosine s, cosine t, plus sine s, sine t. Fill in what we know. Cosine s is 15/17. Cosine t is x over r, so 7/25, plus sine s is negative 8/17. Sine t is negative 24/25. I pull out my calculator to do my math. I get 105/425 plus 192/425. And when I combine those, I get 297/425. Do not give me a decimal approximation. Give me the exact answer. One more time. Suppose that S and T are both in quadrant 2 this time. In quadrant 2, I'm over here, x is negative, y is positive. Find S plus T. I'm going to first sketch S. I'm given that sine of S is 3/5. So that's a 3, that's a 5. I'm going to use my Pythagorean identity to find x is negative 4. So x equals negative 4, y equals 3, r equals 5. Take the time to do that using x squared plus y squared equals r squared. Then I'm going to look at cosine, and I'm going to look at angle T. Angle T is also in quadrant 2. Cosine is a negative 12/13, so I need to find y using my Pythagorean formula again. And it comes out that y is 5. So for angle T, x is negative 12, y is 5, and r is 13. That's the information I need for T. What I'm asked to determine is cosine of s plus T. Now we don't know what the angle is, but we can use our cosine sum identity. That means I use cosine s, cosine T minus sine s sine T. I'm going to fill in those values. And what you should get is 33/65. I am not going to fill in the blanks. I've given you all the bones. You need to be able to do that arithmetic. Okay, we are going to verify these two identities. I'm just going to give you one way to do each of them. But remember that there's multiple approaches. If you were in the classroom with me, we would be getting approaches from different people. But you guys are just going to have to suffer through with me. Okay, I'm going to choose to take the more complex side. The more complex side is right here with secant of pi plus x. I do not have a secant sum identity, but I know that secant is the reciprocal of cosine, and I have a cosine sum identity. So here we go. 1 over cosine pi cosine x minus sine pi sine x. That's my cosine sum identity. Fill in what you know. I know the cosine and sine of pi. Cosine at pi is negative 1. So that's negative 1 times cosine x. Sine of pi is 0, so that goes away. So I have 1 over a negative cosine x, and that, look at my goal. The reciprocal of that is a negative secant x, and I'm done. I have verified. You guys do this next one. We're still using we don't have secant difference identities, but we have cosine difference identity. Use your identity. Make sure you're showing me these steps, that you're not making grand jumps from one thing to another, so that I know that you know what you're doing and you're not just writing something down and hoping that I pass you because we're not in class together. Cosine of 3 pi half is 0. Oh shoot, I was talking and not paying attention to my identity. That should be sine 3 pi half and sine of x. Sine at 3 pi half is negative 1. And I have verified the identity. All right, that is all of 5-3.